What if the most dangerous thing in the universe broke out of prison and it's still out there? Right now, as you watch this, a black hole the mass of 20 million suns is tearing through space at 2.2 million miles per hour. It didn't wander off. It was launched by one of the most violent events the universe is capable of producing. And here's the part that nobody expected. Everywhere it runs, it leaves stars behind it. Brand new ones, formed in the wake of something that should only destroy. Hubble found the clue, Keck built the case, and the James Webb Space Telescope just delivered the proof. And scientists are still processing what this means for everything we thought we knew about the universe. Stay with me, because this story gets much stranger. Let's set the scene. Every large galaxy in the observable universe hides a secret at its center. A supermassive black hole. Not the relatively modest kind that forms when a single massive star collapses and dies. We're talking about objects so massive they can swallow millions, sometimes billions of solar masses inside a boundary you can't see, touch, or return from. Our own Milky Way has one at its center. It's called Sagittarius A star, and it sits there, anchored, stable, going nowhere. But the black hole Webb just confirmed? That one ran. And to understand how something that massive gets hurled out of its own galaxy, we need to talk about what happens when not two, but three black holes end up in the same place at the same time. Galaxy mergers aren't rare events. In fact, our own Milky Way is heading straight for the Andromeda Galaxy right now. Don't panic, it won't happen for another 4 billion years. But when galaxies collide, something extraordinary happens at their centers. Each galaxy brings its own supermassive black hole to the collision, and these two giants begin a slow, violent, multi-million-year spiral toward each other, bleeding energy as gravitational waves with every orbit. Think of space-time like a stretched rubber sheet. Every single orbit, these two monsters warp and stretch the fabric of space around them, losing energy, edging closer, until the inevitable. Now here's where it gets really dark. In the case of RBH1, astronomers believe a third black hole entered the picture. When a galaxy with its own black hole collided with a galaxy that already had a black hole binary, a pair locked in orbit, the newcomer destabilized everything. Gravitational interactions between three massive objects at close range are chaotic in the mathematical sense of that word. Think of it like a cosmic game of pool, but the balls are each 20 million times the mass of our sun. One of them had to lose. The gravitational interaction became a slingshot, and one black hole, the one we now call RBH1, was the projectile. Scientists call the physics behind this the gravitational recoil kick, and in RBH1's case, it was powerful enough to reach 954 kilometers per second, roughly 2.2 million miles per hour. For perspective, that's about 3,000th the speed of light. That's about 1/3 of 1% of the speed of light. And nothing in this galaxy is going to slow it down. 20 million solar masses of raw gravitational force, untethered, unanchored, running. Here's where the story takes a turn nobody predicted. Trailing behind this runaway black hole for 200,000 light years is a chain of brand new stars. 200,000 light years. That's twice the full diameter of the Milky Way. How does that happen? Picture a speedboat cutting across a still lake at high speed. The boat doesn't just move forward. It disturbs everything around it, compresses it, drags it, creates a structured wake of displaced material. RBH1 is doing exactly this, But instead of water, it's punching through the circumgalactic medium, the vast, diffuse halo of gas that surrounded its former host galaxy. As the black hole's gravitational field sweeps through that gas at supersonic speed, it does something remarkable. It creates a bow shock, the same kind of shockwave a supersonic jet creates when it breaks the sound barrier. And JWST caught this bow shock on camera. The data showed gas at the shock front being violently displaced sideways at hundreds of thousands of miles per hour, a signature that could only mean one thing: something supermassive was pushing through. But what happens behind the shock? As the black hole plows forward, the gas it compresses cools rapidly in its wake. And when dense, cooling gas has nothing to disrupt it, it collapses into stars. Van Dokkum's team estimates that roughly 100 million solar masses worth of new stars have already been born in that trail. And here's what makes this truly unprecedented. Inside galaxies, star formation is messy, turbulent. Supernova explosions routinely blast apart gas clouds before they fully collapse into stars. But out here, in the relatively clean gas of the circumgalactic medium, nothing interrupts the process. The black hole is essentially a star factory on the run. Simulations had suggested wakes like this might glow. Few predicted they would become full stellar nurseries stretching across intergalactic space. Let's talk about why this discovery doesn't just fascinate scientists, it rewrites them. If one galaxy can eject a supermassive black hole during a merger event, then every galaxy that's ever undergone a merger, which is essentially every large galaxy in the universe, could have done the same. And galaxy mergers are common. The universe has hosted billions of them since the Big Bang, which means the space between galaxies, that vast emptiness we always assumed was nothing, might not be nothing at all. It could be drifting with wandering black holes, silent, invisible, moving. We'd only ever detect them if, like RBH1, they happen to be passing through enough gas to create a visible wake. RBH1 is the first confirmed example of something theorists predicted 50 years ago but had never managed to prove: the confirmation of a runaway supermassive black hole. The first time theory became observation. And this changes our understanding of galaxy evolution in ways astronomers are still working through. If runaway black holes are common, they could explain things that have puzzled astronomers for years. Galaxies whose central black holes are mysteriously smaller than expected. Diffuse star formation found far from any galactic disk. Black holes that simply aren't where they should be. RBH1 might be the key to every single one of those mysteries. But there's one more thing to sit with. Those stars forming in that trail, they're forming with no galaxy around them, which means planets could be forming there too. Worlds with no galaxy to call home. Imagine standing on one of those worlds at night. No Milky Way arching overhead. No neighboring stars millions of light years close. Just the ghost of a glowing trail where your sun was born, and a universe of distant light that doesn't know you exist. So how exactly did we find this? It took 3 telescopes, and it started with a mistake. In 2023, Pieter van Dokkum's team at Yale was reviewing archival Hubble Space Telescope images when they noticed something strange alongside a distant merging galaxy pair, the Cosmic Owl. A streak, so faint and so strange that the team initially thought it was a satellite crossing Hubble's field of view, an artifact, not real. But it didn't go away. Follow-up observations with the Keck Observatory in Hawaii revealed spectroscopic signatures of hot, young blue stars and measured a mass at the streak's tip that could only belong to something in the range of tens of millions of solar masses. Compelling evidence, but not proof. So, the team turned to the James Webb Space Telescope and its near-infrared spectrograph instrument to settle the debate once and for all. What Webb found was unmistakable. At the very tip of the streak, right where the black hole should be, the gas velocity jumped by 600 kilometers per second over a distance of just 1 kiloparsec. That kind of sharp, localized velocity discontinuity can only be produced by one thing: a supersonic massive object driving a shock wave into the surrounding gas. The bow shock signature, the smoking gun Van Dokkum had been searching for. It's worth noting, the paper describing this confirmation is currently a preprint, submitted to the astrophysical journal Letters and awaiting full peer review. That's standard scientific practice for a discovery this new, and the data is already being scrutinized by astrophysicists worldwide. The physics is clear. The signature is real. RBH1 is real. Here's what I want you to hold on to. The universe has likely been doing this for billions of years. Long before our sun ignited, long before Earth formed, long before the first human looked up at the night sky and wondered what was out there. Supermassive black holes have been breaking free of their galaxies, hurling themselves into the dark and building stars in their wake. And we are only now beginning to see it. Van Dokkum himself says the obvious next step is to search for more. Now that we know what to look for, the bow shock, the star trail, the velocity signature, more almost certainly will be found. Each one a black hole that broke free, that escaped, that went on to build new stars, maybe new worlds in the most isolated, unlikely corners of existence. And here's the thought that should genuinely unsettle you. The universe we thought we understood, where black holes sit obediently at galaxy centers, where the space between galaxies is silent and empty, where star formation only happens inside galaxies, that universe was incomplete. The real universe is more violent, more creative, more alive than we ever gave it credit for. A black hole 20 million times the mass of our sun is out there right now, tearing through the circumgalactic medium of its former home, building a river of stars 200,000 light years long, and it has no idea we're watching. If this just changed the way you see the dark between the stars, you know what to do.